Hello everyone. Today I'm gonna explain how to interpret the coefficient of a multiple linear regression when we have interaction effect. And we will gonna look at two cases. The first one we have interaction effect of ability with mother education, and the other we have age interact with itself. So I want first to go to Calc 1 and we understand the rate of change quickly when we have like x squared. As we can see, the slope is changing, and it's not the case when we have linear. The slope is straight line; it doesn't change. So we don't have a fixed slope. So as we can see, that the change from one point to another is not the same. So it will be different, right? So it's not the same. Like when we have x, this is the function y x squared, right? When we substitute here 2, we get 4. Then if we increase by 1 unit, let's say substitute 3, okay, when we have 9. So the change from here to here was by how much? 5 units, right? But now let me substitute 4 in the x squared, we have 16. From 9 to 16 is 7, right? But let's assume we have 2x plus 1. If I substitute 2, now I have 5. This is increase. No, let's take another number. 3. I have 7. Let's take 4. I have 9. It's fixed, changing by 2 when I increase by 1 unit. So in simple linear regression and even multiple linear regression, we have other things constant. We can interpret it in this way. But when we have multiple linear regression and we have interaction effect within it, we will have a curve like this, and it will be this relationship: first change by 5, then by 7. So in Calc 1, we studied that one way we can get the slope is, I want to know the slope at this point. It's 3, right? So I take the derivative. This is my function, right? If I take the derivative, it is 2x. Then I substitute 3 is 6. The slope at point 3 is y bar is 6, right? So let's see, okay, y x squared, right? If I substitute 3 in it, it's 9. Then let's increase it by 1 unit. It will be 4, right? So we have 16. It's changed by 7. Why is not the same? Because this is an estimation. It's not, we cannot, it will be wrong as we increase the units by a lot. But in derivatives, we want to see small change, not 1 unit, maybe 0.1 units or 0.2 units. But this is good estimation. Still, it's just small, just one difference. So we can see that how we can get the slope of a curve, but it will change at many points. So let's take another example. Let's say we want to see this change at a point x equal 4, right? It is 4, and when we take the derivative, it's the same. We substitute, we have 8. So when you substitute in the x squared, substitute 4, it's a 16, right? Then we have substitute 5, we get 25. As we look at the difference is the 9. So it's very good estimation. And if we substitute not 1 unit, we didn't increase from 4 to 5. No, if we substitute 4 to 4.5, the error will decrease. So this is uh, why we do the part when we calculate the average partial effect, we take the partial derivative, and it is the same. We say partial derivative, not just the derivative, because we have many variables, and we will ignore the other variables, and we'll just will do the derivative for our target variable. So let's take this case, and when we do the derivative for ability, when we do the partial derivative for ability, we will treat all other variables as constant. So method education will treat it as a constant, and any constant, the derivative of it is zero, right? So will be zero, this is zero, and any constant will be considered zero. So we have ability here, and we know that 5x, the derivative of it is what? The constant, only 5. So here, the let's take ability first. We have the ability to it will remain beta 1. And when we take the mother education, it will be 0. And here, mother education is constant and beta 3 is constant. So ability, we will take derivative of it, it will remain for us beta 3 mother education. Let's take it, when treated as a constant, let's say this is 4, for example, and this is like 3. So treat it like 12 ability. That will remain what? 12. So the same idea here. And if we do it for the other, like mother education, we will have this number. So it's the same here, but and the derivative, the change will be different, depends on the value. And now we want to interpret the meaning of average partial effect, but it's hard to know what it really means and why it means like that without seeing the derivation of it. Oh, the manipulation, algebraic manipulation. And maybe you wonder that why I have these in blue, because after redoing all these steps, we will have these, as you can see, the for the last line here. So we will have them here. And in the average partial effect, we just substitute the ability with its average and mother education with its average here, and we will get the average partial effect. And let's explain now. Let's take this example, this equation. I have ability, I have mother education here, and I have the interaction of mother education with ability. So I went to Stata and I did the regression, and this is my coefficient. This is my result. But now I as because we have the interaction, it's hard to interpret it. So we will do algebraic manipulation to like kind of remove this effect. And essentially what we what we are gonna do is we want to see how much the effect of ability or mother education, if we increase them by 1 unit, let's say if we increase ability by 1 unit, how much the education will increase or will decrease. The same for mother education. But at what point? Because remember, with our function x squared, we don't have constant slope. So what we are gonna say is we want to see their effect if we are at the average point of someone with average ability and with average mother education, has average mother education, and how much an increase in ability by 1 unit will increase his or her education. Maybe this doesn't make sense now, but we're gonna see when we do the derivation, it will be easier to understand. So the first line, the slide is messy a lot, but I'm gonna explain it line by line, and this is my equation, right? So we are gonna manipulate, and the way we are gonna do it is we will use this equation. I like to use it, and I'm gonna explain why we are gonna use it. But if you use it, you can easily understand. So this line and this line, as you can see the arrow, this arrow here, is the same equation. We reach it, the same one. And how uh, how did we do it? Is uh, and for shortcut purposes, is I changed ability to x1 and mother education to x2 because it's long to write ability and mother education again and again. So our interaction is what? Is ability multiplied by mother education here. So it is x1 multiplied by what? x2. We can write x1 and x2 in another way. Remember, we want to see the effect when we have average at a point of average ability and at the same time with average mother education. So I went to Stata and used the command summarize ability and summarize mother education, and I got the averages. Okay, and I use these averages, and ability we can write it in another way: ability minus the average plus the average. This is equal what? This is equal ability at the end, right? So it is ability, but it is expressed in another form. So we didn't change anything. We just write it in another form. The same with mother education, is I subtracted the average and I added the average again. So like I added 0. If I add 0 to any number, it will not affect my number. It's the same number, but I'm writing it in another way. It's like this is like ability plus 0. So it has no effect. So this is my new form of ability, and this is my new form of mother education. So now I will multiply them. I will multiply ability, which is x1, and mother education, which is x2. So I multiply them. So this is x1 ability. This is x1 bar, which is the average, plus x1 bar, this one. So I put the whole one here. This is the whole. And this one, this is it. But now I didn't write it mother education or just write the number because it will take a long time and space. So I did the multiplication for you here. I multiply this one by this one and this one. Then I multiply this one here, x1 bar by this one and here. Then I got the whole thing. Then I multiply this one here, and I expanded. And here, as we can notice, these are similar terms. So what I did is I summed them up and I got this one. So here I got the general form here, the same as above. But this is not an important thing. This is just to make you see why we are using this. So now as I have my new form, which is this one, I will substitute it where? I substitute it here. This is, remember, this is my equation, right? And I just make it, I bring it down here. And now I will substitute the ability mother education by this one. So we'll do it here. So beta 3 is the same. And now ability and mother education is this one, the whole thing. And now I will multiply beta 3 by this one, then beta 3 by this term. And usually for easier to expand and manipulate, it's easier to make to stop at this move here. don't expand this term, stop here and expand this one. So I expand it and I have this term, or this part. You can stop the video and try to digest the expansion. Now I will take all that, this part and this part, and I will put them here, because all this part is equal to what? To this part here. So I took this and I put them here in the equation. And now I change the variable. So x1, it will be ability here. As we can see, ability, and x1 bar is ability bar. The same for the others. So as you can see here, beta 3, x bar, x2 bar, x1. So this is mother education, this is ability. So I just bring it down and put them. Now we are gonna add the similar term with each other. So I have this constant, right? The intercept. And I have this one. This is constant because the average, it's known. The average here, and beta 3. And sorry, I forgot to explain or to say what is beta, my beta not beta 1, beta 2, beta 3. We're gonna use it from the original regression. When we do the interaction for this, we did the regression for this one, we get this result. And this is my beta 1, beta 2, beta 3, beta naught. So they are known. They are known to us. And this is they are. This is about the average, which is x1 bar, and this is x2 bar. Okay. And now I have this number beta naught. This is my intercept, and I have this constant. So I sum them up here. Okay. And I have ability in the orange, and I have ability here. And so I will sum these coefficients with each other, beta 1 and beta 3 multiplied by another education. And now we have this one. And as you can see, this is the same when we took the derivative. And the same for mother education here. I have mother beta 2, and I have, not this one, we have, yeah, beta 3 with mother education here, beta 3 multiplied by ability, the average, and we have it, this one. And we have this one from the sparse. Remember, I said don't expand it. Yeah, this is the same here. This is beta 3. And yeah, this is it for the expansion, I think. Yeah, we summed up all the similar coefficients, and we have, this is our final form, this one. So now I will plug the numbers. I will plug this one. How I will get them? Beta 3, there is no change on it, but beta 2 now, we will add to it beta 3 multiplied by the average of ability, and the beta 1 will add to it beta 3 multiplied by the average of mother education, and beta naught will subtract beta 3 multiplied by the average of ability multiplied by the average of mother education. And I did in theta, as we can see, beta naught here in the original here before we do the manipulation, and this is my beta 3, subtract from this one here, the same, and this is my average of ability, and this is the average of mother education. So we get 8.542, and we can see it here. The same we do it here. We take the numbers from the original one and from the averages here, and we use the equation here. I just do this one. Take this one. Say this is, can see mother, yeah, Higher education. So I took this one. So this is for the coefficients of mother education. So this is beta 2. You can see this is beta 2 here. And we have beta 3. And we have the average of ability. So and we now we get the new coefficient of mother education, 0.2788. And we validate our result by seeing the new regression, 78. And just clarify more, this is the regression for which part? This is the part. I did regression for this whole this one. It's gonna be clear more when we do the for the second case for the age. And this is simply manipulation. It's not new equation or something, because remember we add 0 to ability and to method education. This will not change anything. And I did in another equation. We did the manipulation here. This is our original equation, and we manipulated to this form. And if you substitute, so now we regress this one and we get this coefficient, and we regress this one and we have these coefficients. This is another example. So if you use these coefficients and you use these coefficients and you substitute income by 8 and age by 27 in these two equations, you will have in the first one you will have minus 11.659, and in the second you have minus 11.659. Try it yourself and you will see. So this is just manipulation. We are just moving things around, and we are not having a new equation or something. But this will make it easier to understand why we are when we are taking the partial derivative, why we interpret it this way. And it's gonna just interpret more, as we can see here. Mother education, if we substitute it by the average, we said we want to see at the average points, right, of ability and mother education. So if mother education is what? The average 12. Let's say for uh, simplicity is 12 and ability 1.7. So let's substitute by 12, 12, right? And the average is 12 also. So this is 0. And ability is it is 1.7, and the average 1.7. We will substitute by 1.7 and the average is 1.7. So it will be 0. So this whole term will disappear when we substitute with the average. And when it disappears, now I have just this part. And this is with what? This is with normal. It's like the normal multiple linear regression without an interaction effect. And now we can use the normal interpretation, which is an increase in 1 unit of ability, holding everything constant, will increase my education by 0.5599. The same for mother education, holding everything constant, and increase by 1 in my mother education will increase education by 0.2788. But this is at which point? This is at the point of average ability, which is 1.7, and average mother education, which is 12. And to get this one, to get this coefficient without doing all these steps, you can just take what you can take the average, take the partial derivative, and you substitute the what you substitute the average of ability here and beta 2 beta 3, because remember beta 2 beta 3 here, this is the same as this one, sorry, same as this one, and Oh, this is the partial derivative of mother education. So this is they are the same. The- This one we attained it or obtained it from the partial derivative, and this one we obtained it from the derivation, and they are equal. And we substitute here, and we got what? 0.2788. So instead of doing all that, we can just take the partial derivative. But for the sake of understanding, we have to derive it and to see why when we take the average, uh, we take the partial derivative and we substitute the average, why it doesn't mean like that and why we can interpret it this way. Now let's see with another example. We have net financial asset and we have this equation in the first line. And I'm not gonna explain it like this one in detail, but we did the same one here. I used the general equation here, this one, and then I expanded. Then I reached this one. Then I substitute beta naught, beta 3, beta 2, beta 3, and I got my new coefficients, which way we will gonna they will be equal to what? This is my intercept, and I substitute. I get minus 17, and this is the same here. This is my new constant, and I use the original coefficient of this regression for this equation. And this one we can interpret it as at age 25, if we increase age by 1 unit from 25, we will have an increase by what? By the average partial effect, which is minus 0.04369. We will have a decrease. And this is the same here because at 25, this is our derivation after we do all the steps as we did in the previous example. If we substitute 25 here, 25 minus 25 will disappear and you will have just normal things. So you can interpret it at the same way. But remember, this is only valid interpretation at age 25. At age 25, an, an increase 1 unit in age will lead to an increase or decrease by theta 2, which is this one here, at age 25. And also we can interpret income in the same way. At age 25, an increase in income by 1 unit, it will increase my income by beta 1, which is 0.8248. And we can see the average partial effect from the coefficient here, or just we can use what? We can take the partial derivative. And the income can interpret it in any way we wish, because it doesn't have interaction with another variable. So and even if we took the partial derivative of it, it will be equal just to beta 1, because we'll treat other things as constants, it will disappear. So it doesn't depend on age in this example. And as I said, this is just manipulation for the multiple linear regression that has interaction effect, just to see how things will cancel out and it will remain to you just the normal terms. We can see here and we can see it here, and you can do it with any value. Here we have done it with the averages, and we have the averages here, and you can do it for specific values like 25 here. So any value substituted in the partial derivative, we take the partial derivative here, we substitute 25, right? So let's say if we substitute 27 instead 25. So when we do the derivation, we'll do this to 27, not 25. So this is just to make you know how to derive it, whether it is on the average or in the in any number you want. And it will give you the same conclusion as we take the partial derivative, or you just try to derive it and you will have same result. And you notice here is not average here. It's just you can substitute any number. You can substitute the average or can substitute any number. Here is the same. You can substitute the average of age and you have the average partial effect, and you can substitute any number like 25, and we will call it not average partial effect, but we will call it marginal effect. So I'm gonna end it with to remind you with this with the same introduction uh, talked about. It's not about the average, but at any point you can do it because the slope is changing, and this is the same with our function x squared. We want to see the slope at any point. We want to see it at age equal 3. We'll substitute here 3. We want to see it at the average. We'll here. Let's say the average here. We substitute the average because the slope is changing. And this is why we take the partial derivative, and to see the the partial derivative and the result that we obtained from the partial derivative, which we call it when you substitute the average partial effect. If we want to see it, we will do the derivations, and we see that the equation we get from the derivation or the new coefficient of ability is the same one when we do just partial derivative. And just to conclude things, let's summarize the interpretation. And as we can see here, we substitute the average of ability, substitute the mother education here, this quote will disappear. So it's the same our function. We want to see the slope at the point of average ability and at the point of mother education average. So with someone with an average ability and an average of mother education, an increase in of 1 unit in ability will increase his education by 0.5599, and and with another person with an average also ability and with average mother education, an increase 1 unit in mother education will increase his education by 0.2788. And this is the same conclusion when we do with the partial when we do partial derivative, but here it's more clear after we do the derivation. I know maybe my explanation wasn't so straightforward, but believe me, I didn't find a good way to do it, especially because all things depend on each other. So maybe if you watch it the first time, it's confusing, but if you watch it the second time, you will fully understand what we have done. And I found it very important to explain this point because this point, when I understand th- this idea, it makes regression more understandable for me. So I hope you enjoyed the video and you understood what we have done. And sorry if it was more confusing for you. Yeah, and thanks you for watching, and that's it for average partial effect.